Hello, thank you for watching this video. So in this video, we'll be doing question 4 of November 2023, question paper mathematics paper 2. This is analytical geometry involving cycles. So I'll read the statement and then answer the questions that follow. So let's go. In the diagram below, the circle with center O has the equation x squared plus y squared is equal to 20. The point G is the center of the larger circle. They are saying a common tangent touches the circle at D and F respectively, such that D lies in the fourth quadrant. So let me read this thing again. In the diagram below, the circle with the center O has the equation x squared plus y squared is equal to 20. They are saying the point G is the center of the larger circle, and a common tangent touches the circles at D and F respectively, such that D lies in the fourth quadrant. So let's just look at this thing. So they are saying this equation here, which has the center O, which is centered at the origin, have the equation x squared plus y squared is equal to 20. This is the equation of this small circle here. So they are saying this point G, which has the coordinates t and 0, is the center of the bigger circle, which is this big pink circle here that you can see. And they are saying this tangent here is this line here is tangent to this small circle and big circle at point D and F respectively. That's what they're saying. Okay, no problem. So now we're doing 4.1. 4.1 reads as follows. Given that D lies on the small circle, show that P is equal to 4. So that's saying this point D lies, here is it. Here is D here. It is on the small circle, as you can see. Right? So they wanted to find its x coordinate. So you know the equation of a small circle is x squared plus y squared is equal to 20, right? And your point D, which has coordinates P and -2, lies. This point lies on this equation, on this circle of yours. It lies on the circle, as you can see there. Which means if you can substitute your P there and your -2 at the point of Y, because these are coordinates, this is your x coordinate and this is your y coordinate. So if you substitute your x coordinate here and there, it should give you 20, because this point also lies on the circle. Right? So what that means is, you can say, okay, P squared plus y, which is -2 all squared, is equal to 20. Right? When you're here, you can solve for P, because you can say, okay, P squared plus 4 is equal to 20, right? So P squared plus 4 minus 20 is equal to 0. So P squared minus 16 is equal to 0. Can factorize this? So you have P, you have 4, you have 4. Actually, this should be -4. This is the difference of squares, right? So your P is equal to -4, or your P is equal to 4. But you know that this point is on the fourth quadrant, right? And you know that your x values are positive. So you can't take this one. It should be this one this side. So you have shown that your P is equal to 4. We're done with 4.1. Then we move to 4.2. So we have the coordinates of D to be what? To be 4 and -2. Done. Let's move to 4.2. They're saying E is the midpoint of DF. Determine the coordinates of F. So they're saying this point here is the midpoint between this and this thing. So this to that is equal to this to that. So this is a midpoint. This is a midpoint here. So they wanted to find the coordinates of what? Of F. So they're saying E, which have coordinates 6 and 2, right? Is the midpoint. So midpoint of what? of df. So they want you to find the coordinates of what? Of f, the coordinates of here. They want these coordinates. So you know the formula for the midpoint. We say the x-coordinate of E, which is the midpoint, is equal to the x-coordinate of F plus x-coordinate of D all over 2. And the y-coordinate of E is equal to the y-coordinate of F plus y-coordinate of D divided by 2. You know the x-coordinate of E is equal to 2 is equal to x-coordinate of F. What is the x-coordinate of F? It's what you're trying to find. X-coordinate of F plus x-coordinate of D, which is 4 all over 2. Let's do the same thing for this one. Y-coordinate of E is equal to what? It's equal to 2. Is equal to, let's write the coordinates here, is 6 and 2. It's equal to y-coordinate of F, which is what we're trying to find, plus y-coordinates of D, which is minus 2 all over 2. Then you solve for this thing here. What do? Multiply by 2 throughout, so this is 12. Is equal to x-coordinate of F plus 4 is 2. 4 is equal to y-coordinate of F minus 2. So you solve for your x-coordinate of F. Your x-coordinate of F is equal to 8. Right? And your y-coordinate of F is equal to 6. So F have the coordinates 8 and 6. These are the coordinates of F. Done. Then we move to where? To 8.3. So now we're doing 4.3. They're saying determine the equation of a tangent df in the form y is equal to mx plus c. They want us to find the equation of what? Of the tangent df. Here's our tangent df, right? In the form y is equal to mx plus c. What do? What we need to find first, we need to find the gradient of this line, right? Once finding the gradient of this line, once we find the gradient of this line here, we'll be able to find the equation of the line. So let's find the gradient. Which points are going to? We have 3 points. This one, F, we have E, we have D. So the one that I would use mostly, I would use E and D because they're safer. In a sense that I was given this, and even these coordinates more or less I was given. But these I calculated them the coordinates of F. So I'm choosing to use E and D so that if I made a mistake finding F, I can continue making calculations with that mistake of F. So I'm not saying there's a problem with these coordinates. I hope they're okay. But I'm thinking if there is a mistake, I would not want to continue that mistake going down. So I'll use the natural ones that I was given. This one, D and E. So the coordinates of D are what? Are 4 and minus 2, which were given. And the coordinates of E were 6 and 2, and they were also given. So we'll have to find the gradient first of this line between these 2 points. So M is equal to y2 minus y1 over x2 minus x1. So the gradient of DE is equal to, so this is coordinate 1, coordinate 2. y2 is 2 minus 2 over x2, which is 6 minus 4. So this is 4, right, over 2. So you get that your gradient for DE is equal to 2. Because you said 4 plus 2 plus 2 is 4, 6 minus 4 is 2. So this is your gradient for DE. Then now you want to find the equation of the line. Y in the form y is equal to mx plus c, right? So you know your m is 2, so it's equal to 2x plus c. You need the coordinates, the value of c, right? What do? So okay, take any of those coordinates. So I'll take 4 and minus 2. So y is equal to 2x plus c. My y is minus 2. 2 times x, which is 8, which is 4, plus c. So you have minus 2 is equal to 8 plus c. So c is equal to minus 10, right? Therefore, your equation is y is equal to plus 2x minus 10. So this is the equation of this line here, of this tangent of yours. Because they said, determine the equation of the common tangent df in the form. So here is our equation of the tangent. So I'll write here y is equal to 2x minus 10. So this is the equation of our tangent. Right? So the coordinates of f are what? Are 8 and 6. Done. So we'll move to 4.4. But I will have to clean that board because I don't have much space. And then we'll continue. Let me clean the board. Okay, so now we are doing 4.4. So 4.4 reads as follows. Calculate the value of t. Show all your calculations. What is t? T is this value here. Right? So they want you to find the value of t and show all your calculations. No problem. How do we do this? So we can say, okay, t lies on this line here, right? Lies on this line. So you know that this line of yours intersects the tangent here, and you know that the line, the radius of this circle, it is perpendicular to the tangent, right? You know that the radius of this circle is perpendicular to the tangent. So, which means your gradient of a tangent times the gradient of your radius should be called minus 1, right? You know what the gradient of the tangent is. You found that it was 2. You calculated it when you were calculating the equation of this line. And you found that it was 2. So 2 times m of what? Of the radius. What is your radius? Your radius is this line here, fg. So that gradient of fg equal to minus 1. So 2 times the gradient of fg is equal to minus 1. Gradient of fg is equal to minus 1 over 2, divided by 2, divided by 2. So we have the gradient of fg, which is the gradient of this line. Fine, no problem. How do we get the gradient? So we have the gradient, we found it this way. So when you say the gradient of fg is equal to this. What is f? We know f have the coordinates 6 or 8 and 6, right? These coordinates there. So it was 8 and 6. And g have the coordinates t and 0. The coordinates of g are t and 0. So if you want the gradient of fg, you say y2 minus y1 over x2 minus x1, which is equal to, you can say this is 1 and this is 2. No problem. y2 is what? Is 0 minus y1, which is 6 over x2, which is t, minus x1, which is 8. So the gradient of fg can be calculated this way. It's minus 6 over t minus 8. That's how you can calculate it from these 2 points. But you know the value of this. You know the gradient of fg is called to minus half. So this thing here is called to minus half. It's called to this, which is that. So this is called that. So from this you can solve for your value of t. Right? So you cross multiply here. this time this, minus 12 is equal to minus 1 times t minus 8. So minus 12 is equal to minus t plus 8. Right? So should minus t. Transpose the t to this side and transpose the 12 to that side. So t is equal to 12 plus 8, which is therefore your t is equal to 20. Done. You have found the value of t to be equal to 20. So you know that here you have what? You have 20 here. So another way, which is also similar, you know the equation of this line, you know the gradient, that is minus 1 over 2 as you saw here. You can find the equation of this line because you have these 2 points and find the intersection of these 2 points. It should be the same. So what I'm saying is, you can say, okay, no, actually, you should not. I'm saying, another way you can do this problem. You can say, okay, I know the gradient of fg. The gradient of fg is equal to minus 1 over 2, right? You can find the line of fg in the form y is equal to mx plus c, right? So your y is equal to minus half x plus c. You can find the value of c because on this line you have this coordinate there, which is that one. So you have the coordinates 8 and 6. You can find the line to be y is equal to minus half x plus c. Your y is 6 minus half x, 8 is 8 plus c. C is equal to minus 4 plus c. So your c is equal to 10. So the equation of this line is y is equal to minus half x plus 10. So this equation is for this line here, fg. It's for the line fg in this space. But this point g, the point g, has the coordinates t and 0, right? So you know that the coordinates of this point are t and 0 of g. So which means you can substitute your 0 there, minus half of x, what is it, xt plus 10. So half of t is equal to 10 divided by half divided by half. Get that your t is equal to 20. So this is another way you could have done it. Which means you just need to find the equation of this line and substitute those coordinates and find the value of t. Done. So we move on. So the equation of this line is y is equal to minus half x plus 10. This line here, fg. So I'm going to clean the board and then we continue to 4.5. Okay, so now we're going to do 4.5. What are they saying at 4.5? They are saying determine the equation of the larger circle in the form ax squared plus bx plus cx plus dy plus e is equal to 0. So they find equation of larger circle. That's what they wanted to find. In the form ax squared plus by squared plus cx plus dy plus e is equal to 0. So they wanted to find the equation of a bigger circle in that form. So you know that a natural equation of a circle is in the form x minus a all squared plus y minus b all squared. It's called r squared, where a coordinates of the center, right? So the coordinates of the center here, you know them. It's G, which is 20 and 0. So we can substitute these coordinates of the center there, right? So we will have x minus 20 all squared plus y minus 0 all squared, right? Is equal to r squared. This equation could be complete, but we're all missing our square of the radius. So how do we find a square of a radius? You look for another point, for a point that you have on the circumference of your circle, and substitute it here to find the value of that. So we also have f here to be 8 and 6, right? So you have this x and y. This is your f, x, 8 and 6. So you can substitute your coordinates of f, which are 8 and 6, here to find the value of the square of the radius. So this will be 8 minus 20 all squared plus 6 minus 0 all squared equal to the square of the radius. Therefore, the square of the radius is equal to what? The answer of this thing. So let's patch that and say 8 minus 20 all squared plus 6 all squared. This gives us the square of the radius to be equal to 180, right? Therefore, our complete equation is x minus 20 all squared plus y minus 0 all squared is equal to 180, because 180 is the square of the radius, which is this. But this is not in that form. So let's expand this. Right, so what do we get? We get x squared plus, expand this bracket, because you know how to expand this, because there's two of them. X minus 20 times x minus 20 y squared, plus y squared is equal to 180, right? So let's expand this. So this is 180, this squared, minus 40x, right? Plus 400 plus y squared is equal to 180, right? No problem. So what do we have? Then we group them in that form. So we have x squared, right, which is this. Take that as well, plus y squared minus 40x, which is this. There's no anything, there's no y. So maybe we can say 0y, but there's no need. You can just leave that out. Plus 400 minus 180 is equal to 0. So x squared plus y squared minus 40x, 180 minus 400, 400 minus 180, so it's plus 220 is equal to 0. So I think we just demonstrated that. Because so this time this is x squared, right? This time this is minus 20x, this time this is minus 20x. Minus 20x plus minus 20x is minus 40x. This times that is plus 400, which is that, right? Which is that. And then you take that down as is. And then take this, take the y squared, here is it. 40x, here is it. There's no anything with y, just leave it. Then what do you do? 400 minus 180, which gives you 220. So this is the equation in that form. Then you're done. So we move on. Go to 4.6. What are we doing at 4.6? So they are saying the smaller circle must be translated k units along the x-axis to touch the larger circle internally. Calculate the possible values of K. What are these people saying? They are saying the smaller circle must be translated K units along the x-axis to touch the larger circle internally. Right? Calculate the possible values of K. What is K? K are the units of translation. So let me get another color so that we can try to visualize this equation. Okay, so now, what are they saying? They're saying this small circle must be moved, right? K units to this side so that it touches this circle internally. Right? So, let me talk about circles touching. This is off topic, but I'm just going to do it for fun. So, the circles can touch internally, which is what we're asked to do. So, if two circles are touching internally, if you have a circle like this, which means they touch inside here, or this side, or that side, or whatever way. This is internal touching. So when they touch like this, they touch internally. Because this one, they touch inside the big one. Then now, in a situation like this, if they touch like this, or they touch like that, they touch externally. Right? So these ones, this is external touching, this one. That was the internal touching. Right? This is internal, external touching. So this is the external touching, this is the internal touching. Because you can see these circles are touching inside this one. And these are touching outside. So, here, what we're trying to do, we're trying to get a situation similar to this one here. To the first one. We want this to be moved inside this such that they touch internally. If we move this inside this one, let's say, if we move this one here and it touches, let's say we move this one, this is the other side, this is the other side. If we move like this, and they touch like this, you can see they will be touching externally because this circle will still be outside. Because look, from here, I'm moving where my fingers are sitting. This is the circumference of my circle. So if I move like this, you can see that they are touching externally here. You have this situation here. Right? Let me do it again. From here, move like this, they're touching externally. But if I continue moving, until this finger sits here, look, they're touching externally, they're overlapping. Then now, they're touching internally when they're like this. Because what the finger that was sitting, which is this part of this, if you're thinking about this circle, this part of this circle will be sitting here. Let me repeat this again. The circle are sitting like this. We move them like this. Now, these two circles will be touching externally. Now they're intersecting because you can see your circles are touching up here and down here, right? If you continue, you will see if this one sits here, they will be touching internally. You will have a situation like this. So in this case, these two circles are touching internally. Right? No problem. But look what happens. If we continue translating or moving this circle to this direction, they will touch again here. They will be touching internally again. So which means you can have another internal touch somewhere here. In this area here. So these are the two possible scenarios of this thing touching internally. So this point will sit there, and or when this one is sitting on that area, that's when they will touch internally. Because, let me repeat, look at this black one here. See, if you move this one to the side, now they're touching externally. This is not what we want, right? If you continue, now they're touching externally because this is sitting there and you can see your circle like this because the other side of it is here. But if you continue to this direction, again they're touching externally, internally. So these are two scenarios where these things touches internally. So now the question becomes, how many units should you move this so that they touch internally? So the point is to move this point here, right? So this point must be moved such that this sits here, right? This point must be moved such that this sits here. So this is your K units that you should move it. So this length is your K unit so that this one is sitting there. So now how do we get how many units? So we know that I'm going to clean this. I think I'm done with it. We know that the square of the radius, which is the square of the radius, r squared is equal to 180, right? Which means your r is equal to the square root of 180. What is the square root of 180? Is 6 root 5. Which means the distance from here to here is 6 root 5. From here to here 6 root 5. From here to there 6 root 5. Right? No problem. So, I'm going to clean this because I won't need them this much. Right? So, here we know this is 20, right? 20 x value. So this point here, the distance, this distance here, you know it's your radius, right? It's what? It's 6 root 5. That's what it is. It is 6 root 5. So if you want to move, if you want to know what the value of thing is, you must subtract this 6 root 5 on this 20 of yours. Because this is 6 root 5, right? This distance. But let's say now, this distance was 5 units. Let's say for some reason this distance from here was 5 units. You would know that if you want to know what this is, it will be 20 minus 5. So that you know that this point would be 15 units. Because you know that it's 20 here. So this point that you want to know is 5 units away from this. So since it's 5 units away, it should be less, it should be 5, it should be 20 less 5 or minus 5. So you know that your distance now is 6 root 5. So if you want to know what that distance is, it should be a 20 minus 6 root 5. This is that position. If you want to know the one on this side, to move all this way here, you move this distance, which is what? 6 root 5. Which means you add 6 root 5 units on 20 to get to that. So the coordinates of that point, of that position, are 20 plus 6 root 5, which is your radius. It's 20 plus 6 root 5, which is your radius, which is that. So what do we do next? We say, okay, we know that here, the square of the equation of this line was this, of the circle was this. The equation of the circle was this. So which is the square of the radius of this circle was 20, which is your r was equal to the square root of 20, which is equal to what? Something like 2 root 5, I think. Well, let me double check. Yeah, it is 2 root 5. So you know that the radius now from here to the center to this thing, the coordinates, the x coordinate here is equal to 2 square root of 5, which is from 0. And from here, it's minus 2 square root of 5. No problem. So now, what you want to move from this point here to that point there. So you're asking yourself, how many units should you add on this to get to that point. You want this to be sitting there. So you're asking how many k units? How many k units, which is these units here? You must add on this one to get to that. So how do you do this? You say, okay, I have my starting point, which is minus 2 root 5, right? You want to add k units so that this point here is sitting right there. So you want it to sit, to add k units such that your final answer is what? Is 20 minus 2 or minus 6 root 5. So these are the units that you'll be adding on that point. You want to add these points here so that this point is sitting there. So you can solve for k. Your k should be equal to 20 minus 6 root 5, right? Plus 2 root 5. So it looks like your k is something along the lines of 20 plus 4 root 5. Actually, minus 4 root 5. Looks like k is something like this. But let me double check. So 20 minus 6 root 5 plus 2 root 5. So this is your possible value of k. If you want this to sit there, no problem. On the second spot, you want this one to sit there. So which on this x value here, you must add k units so that it sits at that point. So what do? You say, okay, on my 2 root 5, right, which is this point here, I must add k units so that this position is sitting exactly there. What is there? What's there? You have 20 plus 6 root 5. So your k is equal to 20 plus 6 root 5 minus 2 root 5. So your k is 20 plus 4 root 5. So these are the possible values of k. So in short, you can say your k should equal 20 plus or minus 4 square root of 5. That's it. And you're done. Done with this question. So we'll move to the next one, question 5, which is the trigonometry. Thank you for watching. Cheers.